So our final speaker for the afternoon session is Ashley Trussler, who is a Commercial Analysis Manager for Origin Energy's generation area. Ashley's kindly stepped in today in place of his colleague Matt Hallam, the Principal Advisor for Generation Services, who's had to attend a family emergency. So Ashley's kindly suggested here that if you have any questions, he'll email them to Matt another time. However, I'm sure he will have much to add to our proceedings. Ashley, thank you.
Thanks, Jamie, and thanks to the AWA as well. So a bit about my background. I'm an accountant by trade, so don't hold that against me. But these days I'm more into the financial analysis, valuation side of things. So this afternoon I'll give a presentation which covers a few things. So firstly, Origin, who we are in the energy industry within Australia, and a bit more broadly internationally. Current trends within the Australian electricity market, including demand trends that were mentioned before. The critical role that water plays within generation, and a few of our activities in terms of water use, conservation with some case studies. So firstly, a bit about Origin. For those that don't know, we have around 6,000 megawatts of installed capacity around Australia. So it's a large and diverse portfolio of power generation. So we have a black coal-fired power station here in New South Wales near on Lake Macquarie, 7 gas-fired power stations, 1 baseload and 6 peaking, 1 hydro station, again here in New South Wales, our Shoalhaven scheme, and a wind farm as well. Over 4 million customers Australia-wide, so obviously these customers place a lot of scrutiny on what we do and how we operate and how we manage our operations. And also, I guess, within the gas side of things, over 20,000 petajoules of gas reserves. So I guess all that means we're a significant player within Australia. And also on the right there, renewable options significantly in New Zealand through our interest in contact energy, in geothermal and hydro, also within Chile and Indonesia. I guess protecting water resources. So I guess safe and efficient management of water is critical in project development and operations. And I'll give an overview later, but decisions about equipment installations when constructing power generation assets can have a big impact on water efficiency and water use. And obviously the way we use and manage water within operations, obviously a key interest to stakeholders, and minimising water use will obviously lower production and the cost of energy to electricity customers, and also minimise impacts on the environment. So the largest use of water within Origin is within the LNG and generation businesses, so the extraction of coal seam gas, and particularly within generation, the operation of Eraring Power Station here in New South Wales. So today I'll be focusing on specifically power generation. So a bit about the mix of electricity generation across Australia. So on the left-hand side, you can see about 3/4 of Australia's electricity needs are generated through coal, either black or brown coal generation. Now, coal can be a very water-intensive process, depending on the design of the facility and also the location. So where a coal-fired power station isn't located on the coast, you'll need a water source such as a lake or a dam to help there. Natural gas is around 14% of Australia's current energy use in terms of volume. This may shift in the future with LNG plants coming online and gas being exported offshore, with the international parity pricing of gas coming into effect soon. And also, as you're likely aware, the renewable energy target is a key debate at the moment. On the right there, it can be seen that a typical bill in New South Wales, around 6%, is made up of green schemes from government programs and the like, and about a quarter of the cost is due to actual cost of generators, and water costs make up a part of this. And over half is due to the poles and wires that are in place. So a bit around the electricity demand trends that we've spoken about before. I guess household demand from the grid is decreasing and is expected to continue into the near future. So this is due to several factors. So firstly, the energy efficiency of appliances, which has been talked about before, technology advances and consumer attitudes and beliefs mean that things like fridges and TVs are using less and less electricity compared to years ago. Secondly, rooftop solar penetration. So rooftop solar now comprises more than 3 gigawatts installed, or around 2% of demand within Australia. So that's around tripled over the last few years. And then it's expected that solar uptake will continue to rise. And thirdly, to a smaller extent, but consumer responses to rising prices, so cost of living pressures, means that consumers are actively trying to consume less electricity. This, coupled with reduction of industrial and commercial loads through things like closing of smelters, means that all this has a flow-on effect for water use within the generation industry. Conversely to this, has been discussed before earlier today, global demand is increasing and is expected to continue. Places like Asia and South America, obviously their energy needs are growing. So now I'll look at why water is so important within power generation. This slide goes over a few things. So firstly, steam production. So I guess in coal and combined cycle gas generation, there's the natural cycle between water being converted into steam, cooled back to water, and then into steam again. So steam production, water is required basically to sort of prevent or try to prevent any impurities being deposited into the boilers and the condensers. So this is sort of deeming water that's sort of recirculated continuously. Secondly, cooling. So significant amount of water is required for cooling. So Origin's Araring Power Station uses salt water from Lake Macquarie for steam condensing and cooling, a flow rate of around 21,000 litres per second. So I think last year it was around the 2.5 million megalitres per year amount. Thirdly, emission controls. So high quality water can be injected at the point of ignition. So this can result in a reduction in emission levels. Fourthly, generation efficiencies and peak power production. Again, water can be used to make the air more dense, with more energy being able to be extracted during the combustion process. Or peak output can be achieved through the injection of water when required on a one-to-one basis, can lead to around a 15% power improvement. And the slide on the right there is a picture of our hydro station, the Kangaroo Valley and Bendila plants. So this enables water to be used, I guess, multiple times. So water can be pumped to high catchments during periods of off-peak, and then being released to lower catchments to produce electricity during peak demand. But also has the additional benefit of being able to move water between catchments for the Sydney Catchment Authority and Sydney Water to be able to meet Sydney's water demands when required. So a few technology responses to water use reduction. So within the generation industry, there's been technological advances. Firstly, air-cooled condensing. So rather than water being used to condense steam, large fans can be installed to blow around the pipes that carry the heated steam to cool that steam down. So this reduces water efficiency, but obviously it has an impact on electricity usage. Obviously it'll require auxiliary loads, so there's that trade-off between electricity use and water use as well. Secondly, recycled water. So plants can use recycled water, either treated effluent being brought to site or actually treated on site. But if it's on-site installations, this can be obviously expensive to install and operate. Thirdly, emission control technologies. Advancements have mean that water injection isn't always required if low-NOx burners are installed. And fourthly, just general business and social awareness. So increasingly there's a move towards triple bottom line reporting where social and environmental issues are just as important as profit. So a couple of case studies. The first here is Eraring. So it's Australia's largest power station, located on Lake Macquarie, as I said, using salt water from the lake for cooling. Following the use for cooling, it's actually discharged back to the lake at a slightly higher temperature with no evaporation. Also, Eraring uses recycled water, again treated effluent in surrounding locations, or it's got a reclamation plant on site. So last year it produced 872 megalitres from its water reclamation plant, which made up over half of its water use needs, or around 4 or 5 megalitres per day. Secondly, Darling Downs, so it's Australia's largest combined cycle gas plant. It has air coolers installed, which is basically a large radiator like you'd have in your car. And instead of using fans to blow, it uses fans to blow ambient air around the condenser tubes rather than water, so it reduces water use. Darling Downs, it's especially important because there's a lack of natural water resource near site. It does have an on-site bore, but there's not much else around there. But again, these air-cooled condensers need auxiliary power to run, which can be up to about 10 or 15% impact. And secondly, emission controls. So this can reduce the level of NOx produced, but again, capital costs and maintenance costs are higher due to this. Finally, a slide to do with renewables. So currently, renewable energy comprises around 10% of generation within Australia. But again, renewables still require, at the moment, fossil fuel as a backup, just to compensate for when the wind doesn't blow and the sun doesn't shine. Hydro plants can use water directly to generate electricity. They take a few forms, so either run of the river or diversion, where gravitational energy from natural river flows are used to power the turbines and to generate electricity. So this might be the case where there's no storage reserves, reservoirs in place. Secondly, pump storage, such as Origin's Shoalhaven plant. So water can be pumped from a lower reservoir up to a higher reservoir to be able to generate electricity in peak times. Thirdly, impoundment. So impoundment, where a dam's used to store river water in a reservoir. So hydro plants have faced a few difficulties to be able to be constructed economically, I guess en masse. Firstly, community concerns, and also the lack of available areas where there's the necessary water flow and pressure to be able to build large power stations. And finally wind farm and solar output. So I guess comparatively versus coal and gas, they use less electricity, less water. But again, so wind especially isn't a reliable baseload generation technology at the moment. That's all I had. Look forward to questions.